Some shirt theme. Yes, most of the themes have to do with articles of clothing. Not all of them, but most of them. School colors. Yes, tomorrow is Energy Tech Charger Day. Tomorrow is Spirit Day for Energy Tech. And so if you have your Chargers gear, such as your shirts that we got from the basketball team last year, I know I'm wearing my Energy Tech sweatpants right now. Again, I'm practicing for tomorrow. But if you're, especially if you're a ninth grader, or if you don't have anything Energy Tech gear, just wear some blue, wear some green, maybe some gray. And if you're wearing green, neon green is the best because that's what Chargers like is neon green. Okay, and so please, we encourage you guys to participate just to have a little fun, switch things up. But I'll try and remind you every day what the following day Spirit Week is, our Spirit Day is, so we can go from there. All right. So we're going to go ahead and jump in and get started. As I said earlier, today we're going to be going through more practice problems by looking at the what is called the crisscross rule in order to try and get chemical formulas for binary ionic compounds. Okay. Just to give you kind of a preview as to what your homework is going to look like today, you are going to have 15 compounds, okay? Sodium chloride, lithium bromide, magnesium fluoride. And what you're going to be doing is we're going to be utilizing what we've already learned about charges and octet rule and ions, and you're going to ultimately try and come up with the chemical formula, which for sodium chloride is NaCl. And so if you watched the ed puzzle yesterday, they showed you how to do kind of like some shortcuts for this. Yesterday, we were thinking about the electrons, and that can be helpful. But ultimately, what is called the crisscross rule is probably going to be most helpful and most efficient. So we're just going to do some examples for that today. Okay, so the first one we're going to start with, and I'd really like you guys to utilize the chat. I'm going to be asking you guys what charges we have and kind of what we're doing. So just utilize the chat. Feel free to share to everybody. There's no penalty if you get it wrong in the chat. We're all just learning. Or you can chat privately to me or Miss Lee if you prefer to do that. Okay, so we're going to start with this one. What is the chemical formula for the ionic compound magnesium iodide? Okay, very quickly, a chemical formula is something like H2O, where you have the element symbol H, the number on the bottom 2 tells you you have 2 hydrogens, and then O, if there's no number, it's an invisible number 1. Okay, and so we're going to be trying to find that for this compound, magnesium iodide. As you saw in the ed puzzle yesterday, naming ionic compounds is hopefully pretty straightforward. You take the metal name at the beginning, so magnesium. So I always just like to write my atomic symbols first. And then iodide, you could look and look on the periodic table and you're not going to find iodide. What you will find is iodine, okay? And that's because iodine, when it forms compounds, you change the name a little bit to make the very ending IDE. Okay, magnesium iodide is the compound between magnesium and iodine. Okay, and so what we're going to do is we're going to use the charges that fulfill the octet rule to help us figure out the ratio in which these two atoms will bond to be happy. Okay, and so what we're looking at is we have magnesium, a group 2 element with 2 valence electrons, and iodine, a group 17 element with 7 valence electrons. Okay. First thing you have to ask yourself, okay, what is the charge of magnesium when it fulfills the octet rule? Go ahead and look on over at your periodic table, which I always link with the Zoom link here, or if you have your paper one, even better. But go ahead and tell us in the chat, what is going to be the charge of magnesium when it fulfills the octet rule? Okay. So Micah, that's going to be your electron configuration. That's exactly right, in which you're losing those 2 valence electrons. Okay, and we got some positive negative disagreement. When we lose 2 electrons, we will have a positive 2 charge. Okay, which I don't know if I told you guys online, but chemists, for some reason, we like to be weird and dramatic. But you will often see me write 2 plus instead of plus 2. It's the same exact thing. Okay, why they do it different, I don't know, just to make things complicated. Okay, so magnesium is going to take a +2 charge. If you look on the periodic table, alert, alert, somebody said life hack in my last class or the last week when I showed this. If you look at magnesium, in the top corner, there is a little old +2. This is officially known as a selected oxidation state but you better believe that that is going to be the charge that fulfills the octet rule. Okay, and so if you ever are unsure about what the charge of an ion is going to be, just look at your Regents periodic table and it will be right there. Okay, so now we have iodine. Iodine is group 17 with 7 valence electrons. What is iodine's charge going to be when it fulfills the octet rule? Very good. Alex typed it in the chat first. Jason, Jennifer. Okay, if you are ever unsure, we are going to just double check with our periodic table. Iodine's number 53. And if you look right here on top of iodine, you have a -1. The charge that is on the top will be the one that fulfills the octet rule and is the most common charge for that element. Okay, so iodine is going to be -1. And so a lot of people might be inclined to just say magnesium iodide's formula is MgI or Mg1I1, but that's not going to work out. And the reason why is because magnesium wants to lose 2 electrons, hence the +2 charge, but iodine wants to gain 1. Okay, and if I give 1 to iodine, fine, iodine's happy, but magnesium will not be. Okay, so yesterday we were looking at, like, in general, conceptual, the drawing. Some people are getting it in the chat already. You can use what is called the crisscross rule to figure out the ratio to make everybody happy in the most simplified form. Okay, and so what the crisscross rule is exactly what the name suggests. You're going to take the number from the charge. So I'm going to take the number 1 from iodine's -1 charge, and I'm going to crisscross that over to the subscript position for magnesium. Okay, that means I need 1 magnesium ion. I'm going to show you this in drawing here in just a moment. I have iodine here. I'm going to take the 2 from the +2 charge and crisscross that down to the subscript position for iodine to get I2. When I write my final chemical formulas, I'm going to get rid of the charges, I'm going to get rid of the arrows, and I'm simply going to have Mg1I2, in which I have 1 magnesium ion bonded to 2 iodine ions. Now, chemists are lazy. If you look at Andy's response in the chat, he is missing something that I have up here, and that's because Andy already knows the lazy chemistry ways. Just like math. If you were in math class and you had 1x, you would typically just write x. Okay, and chemists are exactly the same. Anytime there's a number 1, they get rid of it and they just write the symbol and the invisible number 1. Okay, so Ms. Garcia, I get the crisscross, but why are we doing this? Why does this make sense? I'm going to try and walk you through it by using kind of what we were learning yesterday. Okay, so I'm going to try this new. I have new technology, everybody. It's very exciting over here in the Garcia household. I have my lovely little iPad share screen, and it's like a little whiteboard, so I can write notes to you guys and say hello, or I can go through chemistry examples. Okay, and so that's what I'm going to do first. We have Mg I2. Okay, we have an invisible number 1 there, so if you want to put the 1 there, you can. If it makes your life better, do your thing. What this is saying is that I'm going to have 1 magnesium ion, which we know has a +2 charge, and I'm going to have 2 iodine ions, which now have a -1 charge. And so why did this work out? It all goes back to what we were doing yesterday. If we start with magnesium, magnesium starts off with 2 valence electrons. Iodine starts off with 7. And if I want to get rid of this electron, iodine only has room for 1. And so what has to happen is magnesium has to find somebody else to take that second electron. And because we're just doing binary compounds, magnesium's just going to find another iodine that also has space for it as well. And so ultimately what you will be left with is you will be left with magnesium, who has lost the 2 electrons, hence that it's empty. And we have 2 iodine ions. And I'm going to color code it here. You guys get to see how messy Miss Garcia's handwriting is, that have each gained 1 electron from that magnesium. Okay, and so what this chemical formula tells you is that I have 1 Mg ion and that I have 2 iodine ions. Okay, and so wow, I can't spell either. And so when you're looking at a chemical formula, the numbers on the bottom tell you how many of that element you have. I have 1 magnesium bonded to 2 iodines, okay? So hopefully this was a little bit of a visual proof to kind of explain to you how this works, but I'm going to show you mathematically why the I have to sneeze, why the crisscross rule is what we want to do. Okay, and so I'm going to go back over to the PowerPoint, and we're actually going to go through the example that was in the video yesterday. And I was very happy to see a lot of people emailing questions about this compound. And it was the compound between aluminum and sulfur. Okay, and so we're going to go through this one step by step. It was the one at the very end of the video, they threw it at you. And I'm going to show you, number one, how to find the formula using the crisscross. We're going to review how to name, but then I'm going to do some math to prove to you why this crisscross rule works and why we want to do it. Okay, so let's start again from scratch. Aluminum and sulfur. I have aluminum's atomic symbol is Al, its atomic number 13. And I have sulfur, whose atomic symbol is S, atomic number 16. First thing you want to do is write those symbols and then look at the charges. And by the way, the metal always comes first, always and forever comes first, okay? What is the charge of aluminum going to be when it fulfills the octet rule? What is the charge of aluminum going to be? Okay, we have one answer in the chat. Let's get a few more. 2 answers that agree with each other, 3 answers that agree with each other. And good, if we peek on over at our periodic table, aluminum number 13 has 3 valence electrons. And look, it only has 1 charge in that top corner. It is +3. Very good. So aluminum is going to lose those 3 electrons to take on a charge of +3. What about sulfur? What is sulfur's charge going to be? John was ready, everybody. Skylan was ready. It is -2. Okay, sulfur wants to gain 2 electrons to get a -2 charge. And so looking at these, this is not going to work out. I have aluminum that wants to lose 3 electrons, but sulfur only has room for 2. So aluminum can give 2 electrons to that sulfur and make sulfur happy, but then aluminum's left sad with 1 extra electron that it really does not want. So we're going to crisscross, okay? Crisscross is going to be the shortcut, and I'll prove to you why it works again here in a moment, okay? You could try drawing it. If you think you know the answer, put it privately in the chat to me or Miss Lee. Don't expose the answer. No spoilers in here, okay? Alex, that's great. And so what you're going to do is you're going to take the number from the charge. Do not take the positive or the negative, just take the number. I'm going to be the 3 from the +3 and crisscross it down to the subscript for sulfur, okay? Meaning I want 3 sulfur ions. I'm going to take the 2 from the -2 charge and crisscross that down to the subscript for aluminum to have 2 aluminum ions, okay? And so what I'm going to do to write my final chemical formula is I'm going to get rid of all this stuff and I'm going to write Al2S3. What this means is that I have 2 aluminum ions, which have a +3 charge still. We just don't put the charges in the final formula because that's not proper notation, bonded to 3 sulfur ions that have a -2 charge. Overall, this compound is going to have an overall charge of 0. Okay, and that is because if you have a net charge of 0, that means everybody has taken the electrons they wanted, everybody's given away the electrons they've wanted, there's nothing extra, everything is perfectly balanced out. Okay, and so we'll do it now. And so what I'm going to do is I'm going to show you mathematically why this octet rule, this crisscross rule works. And I'm going to show you a skill that we'll use later on in the year where you're going to be calculating the net charge of an overall compound. Okay, because as they mentioned in the video yesterday, you always want to have a final compound with an overall neutral charge. Okay, so I'm going to attempt to do some color coding here. We have aluminum, which each started with a charge of +3. And we have sulfur, which each started with a charge of -2. When I crisscrossed, I brought this 2 down here, and I brought the 3 down here, okay? Leaving me with the final compound, Al2S3. What that actually means is that I have 2 aluminums that each have a +3 charge, meaning they've each lost 3 electrons. And I have 3 sulfurs that each have a -2, meaning they've each gained 2 electrons. And so to calculate overall net charge, you're just going to add up all of the charges for your compounds. And so I have two aluminums, which each came with a charge of +3. And I'm going to add that to my 3 sulfurs that each have a charge of -2. And from there, you're just going to do math, knowing that the ultimate goal is having a overall neutral charge. 2 times +3 is simply +6. That is the overall positive charge coming from this compound. And I'm going to add that to 3 times -2, which is -6, meaning that is the overall negative charge coming from this entire compound. And when I take these two numbers together and add them, if we were in person, everybody'd be screaming because it's so exciting. What is +6 plus -6? Another way you could write that is simply 6 plus -6. What is 6 plus -6? Thank you, Dean. Thank you, Jennifer. It is 0. And that is the ultimate goal. You are doing crisscross to identify the simplified atomic ratio in which the atoms are all happy, they've all exchanged a perfect amount of electrons with each other in order to have an overall charge of 0. Okay? And so that is what you're doing. You don't need to do any of this proof stuff or anything yet. You will be doing it in a few weeks, but you don't need to do any of this now. What you need to be comfortable with is that first step, which is identifying the charges and crisscrossing to get your final chemical formula, Al2S3. Okay? So what you're going to be doing for your asynchronous work today is you're going to be simply practicing that material. I'm going to go on over to Google Classroom and I'm going to post this assignment. And essentially, I have given you 15 compounds. Oh, wait, there was one more thing we needed to do. Can anybody name this compound between aluminum and sulfur? If you did the Ed puzzle, you learned the rules for naming, which is taking the metal's name first and just leaving it as is, and then taking the non-metal name and changing the very end to IDE. Okay, Micah, you got it. I don't care about spelling when it comes to naming, by the way, because some of them get weird, but I'm going to take the metal name aluminum, and I'm not just going to write aluminum sulfur. As you can see in the chat, everybody is changing the end of the sulfur name to sulfide. And so the final chemical name for aluminum and sulfur's compound is aluminum sulfide. Okay, excellent, you got it. So if we look on over at Google Classroom, I'm going to click reuse post. Let's go a little bit faster. You have December 15th classwork, binary ionic formula practice. And essentially what you are going to do, I'm going to make this due tomorrow at the beginning of school as usual. I guess your school day starts at 9:10, so we'll do that. You are going to have 15 compounds, and I gave you the name, okay? So I have sodium chloride. You're going to go first and identify the metallic ion and its charge, Na+1. Do the same for the nonmetal, Cl-1, and then you're going to tell me your final formula after you have crisscrossed, okay? Now, this is where typing as chemists gets annoying. If you were writing this on paper, it'd be very easy to go superscripts and subscripts. I have told you the little shortcuts up here at the top, where if you want to go in the superscript position or the exponent position, on a PC or a Chromebook, you're going to hit Control period, and it will take your text box up. Or if you are on a Mac, it is Command. Okay, and so if you notice, I was simply typing, I have la da da, and then I type Control period, and it takes you to the exponent's place. Okay, to go back to the standard format, just hit Control period again. Okay, if you need to go to the subscript, it is Control comma, and that will take you down to the bottom here. Okay, I encourage you guys to practice utilizing the superscript and subscript hotkeys because it will make typing in chemistry, remote learning that much easier. Okay, I have reminders of the hotkeys up here at the top. However, I do understand that some of you may be wanting to do the chemistry, but the typing is going to drive you nuts. And so if you have a printer, you can print out this worksheet and answer the questions and then upload a picture. Or if you just want to write your answers for this table on a piece of paper and upload a picture, that is fine as well. Okay, I don't want the technology to be a barrier between you submitting your work and letting me know what you know from doing your crisscross rule. Okay. So that is officially all I have for you today. I'm going to make sure this posted for you. It should be the most recent thing on Google Classroom. I'll go through and organize this here in just a moment. But if you have any questions, you can stick around. Otherwise, I will see you tomorrow on School Spirit Day. And yeah, have a great Tuesday, my friends.
Thank you. Have a
Okay.
good day.
Goodbye, Israel.
Bye,
Goodbye, Imran.
everyone.
Goodbye, John. Goodbye. Goodbye, Micah.